Okay, so today actually we're gonna talk about very important subjects, and I want to start with like a quick refresher. I'm sure you all worked on your homework, so you're comfortable with everything we covered so far, but I didn't show you how to use the table, and in case you need it in the exam, I want to go over some of the examples very quickly. So we talk about time value of money, and we said basically $1 today is not the same thing with $1 next year. And it's not just because of inflation, or it is also because of to get the reward for waiting. So if you don't consume now, and if you're waiting to consume, then of course you want some reward, and interest is your reward. And it has all kinds of information in it, actually. It has the inflation information in it as well. And we said the most important formula, and the most basic formula, is this one. So future value is 1 plus r to the power t. Or if you modify this formula, then it's going to look like this. So with this formula, we can calculate present value, future value, interest rate, or t. So if I give you 3 variables, you can find the 4th one. And now let's look at this example again, and let's do this example using the formula sheet. The table, time value of money table. So it says your job promises a one-time retirement benefit of $100,000 on the day of your retirement. You plan to work for 15 more years and require a return of 8% on investments. What is this benefit worth? So basically it tells you in the future you're going to retire and you're going to get $100,000. So the future value is now known, so we can use this formula. So we are asked to calculate the present value. The future value is $100,000, and then I can write the formula as this: future value times. Okay, I can write the formula like this, right? It's the same formula, and the reason why I want to write it like this is because of the table, and this part is called FVF. I know, ridiculous. And you can actually find this part from the table. So for this question, let's go back. I know the future value, which is $100,000, 1 over 1 plus the interest rate. Interest rate is 8% here, and t is 15. So normally this is how we solve the question, or you can solve the question. Solve this equation with the table. So you can write this part as FVF 8% and 15. So from the table, if you look at the table, if you look at A2, appendix table A2, it says discount factors, present value of $1 to be received after t years. So is this part familiar? So the table gives you this part, basically. So from the table, you can find the related R and T, and you can find the value of this part. So let's try to do this. Number of years is 15, so try to find 15 from the table. Number of years is 15. And then try to find 8%, corresponding 8% in the same row. So the number should be 0.3152. 0.3152. Did you all find it? So this is how you can use the table. So in every table, we don't have to give you something like this in this structure, but you should be able to read the formula, right? So this table A2 gives you 1 over 1 plus r to the power t. That's the table you're supposed to use. So if you use that one, you can find this part. So the answer will be 31,000 something. Okay, so let's use this one more time. Let's look at this one, because the table comes handy if you have a question, if you're asking interest rate or T. because the calculations are more complex in those. So it says, what rate of return will double my money if I invest for 9 years? So I have present value is $1, 1,000, 2,000, it doesn't matter. Present value is $1. And future value, I want to double my money. So if I take the present value as $1, future value should be equal to $2. And it says, what rate of return will double my money if I invest it for 9 years? So T is equal to 9. So from here, I'm supposed to find R. So for this one, I can use both of the formulas. But let's use the first one just because I want to show you another table. You can use the second one as well. So you're going to use this part. And in this part, actually, oops, this part is called PVF. You don't have to memorize those, but sometimes some people are using PVF things, so I want you to be familiar with it. So this part is PVF. And again, you're going to find R and you will try to find R and T for the corresponding formula. So let me erase this part now. Can I erase it? OK. So for this question, present value is equal to 1. Future value is equal to 2. And for PVF part, I know T is 9. And I'm supposed to find R, the interest rate. So this part is equal to 2, right? 2 is equal to PVF, 9 R%. So for this one, which table I'm going to look at? I'm going to look at table A1, right? Because I'm using this part of the formula, and A1 gives me that part. So for that one, what am I going to do? I know I have 9 years, so find 9 as number of years. And then from here, I will try to find the number 2. Why? Because this part should be equal to 2. So with 9 years, with the corresponding interest rate, I should find 2. So from here, try to find 2. And as you can see, at 8%, the number is 1.999. What does it mean? If you take R is 8% with 9 as the numbers of years, then those two numbers will give you the future value over present value ratio, which is 2. So you're basically going from the backwards. Okay. So this is how you're gonna use the table. That's it. I mean, you don't have to use it, but sometimes people cannot calculate like logs and ln's and stuff like that. So if you want, you can use it. Just try it when you're solving the practice questions. Any questions? Okay. Then we talk about perpetuities. Perpetuities are basically infinite number of payments that occur, and those payments are fixed. So every year, every period, you're going to get a fixed amount of money, and it will continue forever. And the formula for perpetuity is different than what we did before. So let's write the formula again. For the perpetuity, you cannot calculate the future value just because the future is infinite, basically. So you have future value, present value formulas. And then for the perpetuity, the present value of a perpetuity was this. And in this formula, there was one important thing to be careful about. It's about the lag. So if your first payment happens at year 3, let's say, this formula will give you the present value of the perpetuity at time 2. So that's the important thing to remember. And I think this is where we left off, right? OK. Let's solve this question and then go over to annuity part. So in this question, it says, in order to create an endowment which pays $185,000 per year forever, how much money must be set aside today if the rate of interest is 8%? So since it says forever, this should be a perpetuity. And it pays you $185,000 per year, and interest rate is 8%. So you have an endowment like this. It starts with and it goes on forever, right? So you have something like this. So in the first part, it says how much money you should put aside today so that you can get this $185,000 every year forever. So what do? You use the perpetuity formula, and the present value will be equal to $185,000 over 8%, which was 2.3 million, I think. 231. Okay, so it is equal to this one. So this part was easy. In the second part, there was something very important. So it says, what if the first payment won't be received until 3 years from today? So it says how much money you should put in the bank today so that you will be able to get $185,000 from the bank. But this time, the question is a little bit different because you will start taking the money from the bank at time 3. So this time, your cash flows will look like this. Right? So this time, what am I going to do? For the perpetuity, I have one formula that I'm going to use. There's forever payment, so this is the only formula I can use. So what am I going to do? I'm going to use this formula to calculate the value of this perpetuity at which time? At which time? So the first payment is at time 3, so this formula will give you the value of the perpetuity at 2. Wonderful. So it's going to give you the values of all the future cash flows at time 2 here. So value at time 2 will be equal to $185,000 over the interest rate. So of course the answer will be the same. Okay. Am I done? No. The question asks me about the present value of it says how much money you should put in the bank today so that you can start taking this money from the bank from year 3 onward. So this time, what am I going to do? I calculated the value of all those future cash flows at time 2. I put them in the basket. So I need to bring the value of this lump sum cash flow, and I should bring it to time 0. Right? So this is the value at time 2, present value at time 2. I need to bring it to time 0. So what am I going to do? This is the value in the future now. I'm going to bring it to time 0. So it's going to be present value at time 0 will be equal to present value at time 2 over 1 plus r to the power 2. So I'm using this formula now. So I'm gonna bring this $2.3 million to time 0. So it's going to be like this. So the value of this, the value of the money will be. So if you put $1.9 million in the bank account today, leave it there forever, and start taking $185,000 every year starting from time 3, this money will be enough enough to cover all of the future cash flows for you. Any questions? During the break, you missed finance a lot, right? You did, I know. Okay, if you're a little bit more awake now, we can start with annuities. Okay, so in the annuity, you will have constant amount of payment, constant amount of cash flows for a finite period of time. So in the perpetuity, it was infinite. It was constant, but in infinite. For annuities, it is finite and constant payment. And there's a difference between ordinary annuity and annuity due, and we will cover it in a second. Let's start with basics. Okay, this is an important topic. Annuities are really important, really, really important. So just try to wake up. I'm going to go step by step. And if you don't understand something, let me know. So it says, how much would you pay to receive $100 every year for the next 4 years if you require a 10% return on your investment? So basically, starting from time 1, you're going to get constant payments of $100 for 4 years. So this is like a multiple cash flow example, right? There is nothing complex here. So what you have, every year you have $100. So you're calculating the present value of all those cash flows at time 0. So what do? You are using this basic formula. So you have the future values. They're all $100, but they occur at different times. So you're calculating the present values. You add them up. You find the value of the annuity, $317. Is there a question here? OK, because it may get complicated soon. So let me know. OK, so this is the part. So what if I give you 50 payments of $100? Are you going to do this 50 times and add them up? No. So I'm going to provide you the basic formula for this, which will look like this. So present value of an annuity will be, let me use the payment again, payments at time t plus 1, let's say. Just like in the perpetuity formula, if the first payment is at time t plus 1, this formula will give you the present value at time t times this part, 1 plus r. Okay. So r is the interest rate, n is number of payments. Okay, don't get fixated on n's and t's. Just try to understand the formula. So you're not going to be confused about C, PMT, T, N. Never mind, but just understand the formula. So this part, again, we're going to use the table later. For this part, it's called PVFA. So we have an A for annuity here. And it's going to use R and T again. Again, this PVF thing, you don't have to memorize. It's just sometimes you take private lessons and instructors are using this, so I want you to be familiar with it. That's it. OK, so this is the present value of an annuity. So for this question, do we have it here? For this question, remember we did multiple cash flow calculations, but instead you can just say, OK, the cash flows are 100 each, R was 10%, and N is 4 because I have 4 payments. The first payments happened at time 1. So this formula will give me the present value of the annuity at time 0. That's it. Constant payments. Just be careful about the schedule of the payments. When do you have the first payment? Just like in the perpetuity part. Just be careful about that part. And here, N is important. This is not the time period you're in. It is about how many payments you're making or you're receiving, let's say. Any questions here? This part shouldn't be very complicated, actually. OK. So let's look at this one. You're purchasing a home, and you're scheduled to make 30 annual installments of $10,000 per year. Given an interest rate of 5%, what is the price you're paying for the house? So annuities are basically mortgage examples, and you will use it in your real life as well. So these are important things. So if you want to buy a house, and suppose that you don't have any cash at all, you go to the bank and you say, I can make only $100,000 installment payments, and you can only pay it for 30 years. So the interest rate is 5% given by the bank, and that's the most price you can pay for the house. So the question says, what is the price you're paying for the house? So how are we going to calculate it? Could you just write down the formula at least? Just write down the numbers for the formula. And please try to use a table as well. Let's see, just challenge yourself, and let's see whether you will be able to read that from the formula, from the table, sorry. Just write down the formula and try to find it from the tables. Very good. So let's solve it with the formula and with the table. So basically it says you're purchasing a house. You can make 20 annual payments of $10,000 per year. So again, draw a timeline. Okay, maybe in this question it's not that important, but it will be important later. So you can make 20 installments, and each installment is for $10,000. Interest rate, the bank offers you 5%, and that's it. What's the price you're paying for the house? So you're gonna use the present value formula. Since you start making the payments at time 1, this will give you the present value of the annuity anyway. So you have $10,000 payments. Interest rate is 5%. And N is 20. You have 20 payments. Or you can calculate this equation, or you can use the table for this part. So what am I going to do now? I'm going to look at table A3. It's an annuity table. And if you can see it, it gives you this part of the formula anyway. Right? It's exactly this part. So from here, I'm going to find number of years, 20. And then I'm going to find the interest rate, which is 5%. So it's going to be 12.46. So this part is 12.4622. So the present value of this house will be 124,622. That's it. That's the present value of an annuity. Not difficult, right? Any questions? Okay, let me continue. You have the answer here for 30 annual payments, because I changed the question. Okay. Okay. This was present value of an annuity. Let's see how we calculate the future value of an annuity. Then we're going to go into more complex stuff. Okay? I promise it's going to get more complicated. So don't fall asleep. Okay, how much would be in your bank account if you deposit $100 at the end of every year for the next 4 years, and your account earns 10% a year? Again, this is an annuity. You're putting $100 in your bank account for 4 years. You know the interest rate, so you have finite amount of payments, and you have constant payments. So what are you going to do? You can treat this as multiple cash flow question, and you can calculate the future value of each individual cash flow and take it to the future using the future value formula, this one. Any questions here? So for this one, you're taking it to 3 periods ahead. So you do 100 times 1 plus r to the power t. For this one, you're taking it 2 periods ahead. So you're multiplying 100 with 1 plus r to the power 2, blah, blah, blah. You add them up, you find the answer. Again, what if you have 30 payments, 50 payments? Are you going to do this individually? No. We're going to use the formula. And the formula will look like this. Let me write down this formula. So future value will be equal to, again, the payments, fixed payments, times 1 plus r to the power t minus 1 over r. Or let me write it as n. So this is how many payments you have. These are the constant payments. The important thing about this formula is that this formula gives you the future value of the annuity at the time of the last payment. So if you use this formula, it's going to give you the future value of the annuity at time 4. Hocam, it's obvious. Just wait. Okay, so it's going to give you the value of the annuity at the time of the last payment, which is exactly here. So for this question, what am I going to do? Payment is 100. R is 10%. You have 4 payments. That's it. Plug the numbers in. You can get the future value. Do I have it here? No, it should be equal to 464. Or we can use the table. This time we're going to look at A4. Future value of $1 per year for each of t years. And this part, tahmin edin ne diyoruz buraya? FVFA. Aynen. FVFA. So for this one, you're going to look at A4. For our question, we have interest rate of 10%. The period is 4. So you have 4 payments, and the interest rate is 10%. So you're going to find the 10%. So it is 4.64. Can you all find it? 4.64. And you are, of course, multiplying with $100 payments, which will give you $464. So you can use the table, or you can use your calculator, whatever you feel like. Or calculator. OK. So this is the future value of an annuity. OK. Another question, just go over it very quickly. You plan to save $4,000 every year for 20 years and then retire. Given a 10% rate of interest, how much will you have saved by the time retire? So it's an annuity question. You're putting $4,000 fixed amount of payment every year for 20 years. And the question asks you how much money you're going to have when you retire, if the interest rate is 10%. So I'm going to use this one. My payments are $4,000. Interest rate is 10%. And you have 20 payments. So the formula will give you $229,000. So if you put $4,000 every year for 20 years in the bank account with 10% interest rate, this is how much money you're going to have when you retire in the future. Clear? Very good. So I'm going to go over the annuity formulas, and then we're going to go one step more complicated. Okay, just a summary first. So what did we do to calculate the present values? So basically, I calculated the present value of all the individual cash flows and add them up. So the present value formula here gave you the value of the annuity at the time just before the first payment, right? If the first payment is at time 1, the formula will give you the value of the annuity at time 0. So there's 1 year lag almost. This was the present value idea. In the future value, you calculated the future value of all the individual cash flows, and we used this formula. This formula gave us the future value of the annuities at the time of the last payment. So these are true for ordinary annuities. In the ordinary annuities, we say that the payments occur at the end of the periods. So here, this is period 0, let's say. The payment happens at the end of this period. Here as well. This is what happens in ordinary annuities. When we have annuity dues, things will change. In the annuity dues, payments occur at the beginning of the periods. Just take it as is for now. Let's go into the example. OK, so here, in an ordinary annuity, suppose that you're going to get $100 every year. And for an ordinary annuity, all the payments occur at the end of periods. That's why I'm saying draw a timeline. So at the end of the first period, you get, at the end of the 0th period actually, you get the first payment. Then at the end of the first payment, you get the, at the end of the first period, you get the second payment, blah, blah, blah. So all the payments occur at the end of the periods. So you have a 3-year annuity. Payments occur at the end of the years. Take the same 3-year annuity and use it as an annuity due where payments occur at the beginning of periods. So this time it's going to look like that. So you're going to take the first payment at the beginning of this period, which is now. So as you can see, kind of, we had this lag behavior for ordinary annuity and annuity due, which will affect our annuity calculations. And I think the easiest way to understand is over examples. Okay, let's look at this one. You're receiving $1,000 a year for 3 years, and you deposit each annual receipt into a savings account earning 7% interest. How much money will you have at the end of 3 years? So this is an ordinary annuity. It's a 3-year annuity, and you're going to get $1,000 every year for 3 years. So basically, in the beginning, you're going to have something like this. So ordinary annuity, you're getting all the payments at the end of the period. So your first payment is here in the timeline. And the question asks you what? How much money will you have at the end of 3 years? Okay, so it says 1 year, 2 year, 3 years. At the end of 3 years, how much money I'm going to have? So you can calculate the future value of the annuity individually or using this formula. You have $1,000 payments with 7% interest rate, and you have 3 payments. So the future value will be $32.15. There's nothing new here. If it was an annuity due, if your payments occur at the beginning of the periods, then what's going to happen? The payments will be like this, right? At the beginning of the periods. The question still asks you how much money will you have at the end of 3 years. So you're still asked to calculate the future value of the annuity at this point. But what happened now? The last payment occurred here, not here anymore. So when you calculate the future values, this value you calculated is different than this one. Why is this higher? Actually, you're keeping the money in the bank for a longer time. You start putting the money in the bank account immediately. That's why you have something higher. So let's go back here. Let's use the formulas. Okay. So for this one, I'm using the future value formula. Okay. Payments. 1 plus r to the power n minus 1 r. Okay. So we have something like this. Okay. So in an ordinary annuity, remember I said this formula gives you the future value of the annuity at the time when your last payment occurs. And you were like, haha, hocam, it's obvious. Remember? Okay. So when you use it as an ordinary annuity here, so future value will be equal to 1.07 to the power 3 minus 1, 0.07, and it was equal to 32.15. Ordinary annuity. Now it is annuity due, okay? So nothing changed. Payments are hundreds. 107 to the power 3. You still have 3 payments. Nothing changed. But this time, this value is at which time? Huh? Exactly. This will give you, again, the formula will give you the value of the payments, the value of the annuity at the time of the last payment. So this is at time 2. So to calculate the future value of annuity, what am I going to do? I need to find the value of it at time 3. What am I going to do? Very simple. You're great. You're gonna take it to time 2. So it is the value, present value at time 2. Let's say you're multiplying it 1 plus r. You're bringing it to time 3. So this is the difference between ordinary annuity and annuity due. So you have to be careful about the timing of everything. And this was a 5-point exam question previously. In one of the exams, I asked this question. So be careful about the difference between ordinary annuity and annuity due. In the annuity due, you have to make an adjustment in the end. Okay. Now let's look at the present value of the annuities. Let's see what's going to change. Let's assume the cash flows of $1,000 a year for 3 years represent withdrawals from a savings account earning 7% compound annual interest, blah, blah, blah. How much money would you have to place in the account right now at time 0 so that you would end up with 0 balance after the last 1,000 withdrawal? Basically, it's trying to ask you this question. So how much money you should put in your bank account today if the interest rate in the bank is 7% and you're going to take off $1,000 every year. This is a question we solved before, nothing new. So you have a 3-year annuity. You have 3 deposits, or sorry, withdrawals, cash outflows. What do? You calculate the present value of the annuity using this formula, right? One thing to be careful about is, since you're taking your first withdrawal at time 1, this formula will give you the value of this annuity at time 0, right? That's the only thing to be careful about. So $1,000 is the payment, R is 7%, and you have 3 payments. That's it. So this is an ordinary annuity. What if this was an annuity due? So it will sound ridiculous, but you're going to the bank, you're putting some money in the bank, and at the same time, you're removing your first withdrawal. So your first withdrawal is at time 0 now. And then you have 2 more, the total 3-year annuity again. So again, what do? You calculate the present values of those cash flows and find the value of it at time 0. So let's look at the difference again. In an ordinary annuity, you should put 2624 in the bank account. But in annuity due, you should put 28. Why? Because you are starting withdrawals immediately. You're not leaving this, you're removing this $1,000 immediately. In this question, you left it for 1 year, so it earned interest. Okay? So the difference comes from where? Or what is the adjustment we should make, let's say. Let me erase this while you're thinking about it. So this time, we are using the present value formula. So if it was an ordinary annuity, what should we do? Payments are 1,000. R is 7%. N is 3. So if you do this, the value will be 2624. Nothing new here. It was an annuity due. Then I need to be careful. In the ordinary annuity, the first payment occurs at time 1. So this formula gave me the value of this annuity at time 0. This time, my first payment is occurring at time 0. Okay, everything is same. The timing changed. So in this case, this formula will give me the value of the annuity at which time? The first payment is at time 0, so it will give me the value of the cash flows at -1. So I need to bring it 1 period forward. So again, I need to multiply it with 1.07, right? I'm going to bring it 1 period ahead. So it will give me 2808. Let me just try to... So did you understand ordinary annuity part? No problems with ordinary annuity, right? Good. The only thing you need to be careful about annuity due is the timing, okay? So the idea is the same. When you calculate the future values, if you remember, you calculate the future value of an annuity using the formula. It gives you the value of the annuity when the last payment occurs. But for the annuity due, since the first payment occurs at the beginning of the period, I need to move it 1 period ahead. So I multiplied 1 plus R. Same with present value. So if the first payment occurs at time 1, the formula will give you the value at time 0, ordinary annuity. But if you have annuity due, the first payments occur at time 0, the formula will give you the value of the annuity at time -1. So I need to multiply it with 1 plus R to bring it to time 0 again. So the adjustment is the same. There's nothing complicated there, actually. Let's take a break, and we're going to go over this one more time.